Hello and welcome to our presentation. My name is Gustav, this is Niklas, and we're representing the Volvo construction equipment team today. The team consists of 8 students here at BTH, but also 4 students over at Stanford University. And we have been working with urban mining.
So, what is urban mining? Urban mining can be described as the idea to harvest the urban environment for materials instead of the bedrock as we do today. It's about developing processes and technology which enables this way of harvesting and allows for transformation into a sustainable mining environment. What will happen if the earth is protected in the future and we cannot continue mining materials in the same way as we do today? What would be the impact if 100% of the materials would have to be recycled, and how would this affect the mining industry? Urban mining tries to answer these questions and many more. So Volvo. Why is Volvo Construction Equipment interested in urban mining? Well, Volvo CE develops, manufactures and markets equipment for the construction industry and other related industries around the world. This means that Volvo is affected by the development in the mining industry. And hence they want to investigate urban mining as a future business segment, and it's better to be proactive than reactive. To start our investigation, we have researched what the following areas look like today: water purification, tires and rubber, municipal solid waste, construction and demolition materials, and electronic waste and appliances. Together, these areas represent a big part of what we believe is the divergent scope of urban mining. During our research and development phase, we tried to look for ways to answer the questions of urban mining. Basically, we tried to look for ways to build the bridge between the old and the new, and doing this in a sustainable way. After our researching phase, we found a solution which we believe is a stepping stone towards a more sustainable mining environment in the construction and demolition area.
So, this is what it looks today when a building is going to be demolished. We have a company, they will demolish the house, they will do some rough sorting on site, put the waste in different containers before it's shipped to a municipal plant. At the municipal plant, they will do some further sorting of the materials before it's sold to a third company. For example, concrete will be sold to a company that will use it for aggregate or filler in new materials. They will then use it to make, for example, new concrete that they can sell to construction companies that can use it to make new houses. So we have a lot of different companies and we have a lot of different transportation back and forth. Sorry. During this project, we've been visiting a lot of different sites and companies, and we conducted interviews at these companies just to see how the material flow today and what the workers at these places think can be improved, or what problems they see in their everyday work. From these, we got a huge list of needs, and this, what you see here, is a summarized list of those needs. We have these needs in mind when we start to discuss and think about our vision and our goals and in our project and in this problem. For example, one big need is that we want to build a product that is safe to use for the users, the workers, but also safe to be around for unaware people that just walks by. And of course, we don't want it to harm the environment in any way. So this was how it looked today, and we want to change that. This is our vision. We don't want to change anything in the demolition or the construction part. However, we do want to move the recycling phases to an on-site recycling instead of transporting the material off-site all the time. And This is just a regular old construction or demolition site. We have a lot of heavy equipment machines that tears down the building and put the waste in different containers. And then we have these trucks here. They will come and pick up the waste from these containers and move it to a municipal plant, and the material will go through the steps I told you before. We don't want this. We want to introduce our product instead. This is a concrete recycling plant that is powered by electricity. Basically, you transport it to the construction site or the demolition site, and you leave it there, and it can operate during the whole process of tearing down the building and building up a new one. Basically, you make new concrete out of the old one. So how does it work then? Well, first of all, we have a 40-foot or 12-meter long container that is very easy to transport by boat, train or truck. And it stands here on a chassis or a trailer when it's in use. And that means that the heavy equipment machines on site can move it themselves on the site short distances. It all starts right here in the front, where an excavator unloads old concrete into this bucket right here, before the old concrete is transported to the crusher in the middle here. And it crushes the concrete down to a small aggregate that we can use to make the new concrete. On the way to the bucket in the middle, where the aggregate is stored before it's used to make the new concrete, we will remove any metals that might be in the mix from, for example, reinforced concrete. We have another two buckets in the middle, where one for sand and one for cement mix that also is needed to make the new concrete. In the end, everything is mixed together right here, and water is added in the mixing screw. The mixing screw will then mix the concrete together, as well as transport it to the outlet right here, before we can use the new concrete to build something new. For example, wall units or tiles that we can use to build a new house. And actually we believe that we can produce 40 cubic meters of new concrete every hour with this machine. And we can use up to 30% old used concrete in supporting walls, and even more than this in products that are less demanding.
So, our product does not only have to be green in this way, it also has to be green in this way. So, to ensure that our product would create economic profitability, we have investigated our product and the environment it would operate in from a business point of view. We'll begin with a business model canvas. A business model canvas is a tool that has allowed us to describe, design, challenge, and invent our business model. The tool simplifies and structures key factors in a business model. And for this presentation, we will look closer at the value proposition. So, we are trying to help our customer create on-site concrete, i.e. providing a tool which allows on-site creation of concrete during the demolition and construction phase. Our product will help our customer to get an environmental approach, which will help them gain public assent. It will reduce the amount of material going to disposal. It will reduce necessary hauling and transportation. It will create a new revenue stream by the possibility of reselling recycled concrete to other companies which make new buildings. Since our tool decreases transportation and the need for external material providers, it will help our customers gain power and control of their own supply chain. So as you can see here, we've done a SWOT, and a SWOT is done to pinpoint key strengths, weaknesses, opportunities, and threats. And we'll begin with the strengths. Our product operates on a new market, and this market is the creation, recycling, and separation of materials. So, as you know, our product will recycle and create concrete and separate the concrete from the metals. And onto a weakness. We have ever-changing construction plans, and they can change even during the construction phase. This affects our products and might hinder its effectiveness. And an opportunity. Our product is in line with future necessities for the market, e.g. new processes and technology which builds the bridge towards a more sustainable mining environment. And threats. We have cheap alternatives. If our product is successful, it can be copied by other companies which can then claim part of our intended market. And alternatively, different cheaper combinations of machines which fulfills the similar customer needs as our machine can be created. When evaluating an idea from a business point of view, it's important to take both the good and the bad into consideration. So we believe that doing this will give us the opportunity to work on fixing the weaknesses and neutralizing the threats. So now I will present a cost assessment built into an example. Right here we have the Meyer Library at Stanford University. It recently went through a complete demolition and reconstruction phase, where transportation was equal to 50% of the demolition cost. 20% of the building is made from concrete. We have estimated that our product would be priced somewhere around $500,000, which includes a 17.5% profit margin, and that our customers would have to have return on investment somewhere around 3 years. In 3 years, it's feasible for a larger demolition company to do around 10 projects. This means that at each project, a $50,000 saving would have to be done. And we think that's highly feasible with our product. And when presenting these numbers, we want you to keep in mind that these numbers are based on estimations and qualified guesses made by us. However, we think that we've come pretty close to reality. It's normal for companies within the mining industry to have a repayment period of their machinery of around 5 years. And these numbers are without taking several other saving possibilities which our product presents into account. So, in conclusion, our product is a stepping stone towards a more sustainable mining environment. It offers savings and reselling possibilities to our customers at a low return on investment. It targets a completely new market, and in that lies the opportunity to redefine not only Volvo's but the entire mining industry's view of market segments. It satisfies the needs that Gustav presented earlier. It relieves labor workers from manual handling of waste. It improves efficiency of transports. It's designed to consider the product life cycle, and it definitely makes better use of waste than current options. And we will continue working on this project until summer, making room for further development, more exact calculations, and overall improvements. That was all for us. Thank you for your time.
Why did you choose to focus on this problem and not any of the other ones, such as electronic waste or rubber tires or any of the other things you mentioned in your lovely pamphlet?
Well, we were out searching for ways to improve the current situations, and we think that electronic waste is pretty developed. There are some major improvements that can be done there, and this was just basically from our idea generation. We found this opportunity, and we sort of benchmarked that or evaluated towards other solutions that we had at that time, and this one came out on top.